Hello! Yes! And welcome to our Objective 6.1 notes, Operations with Rational Expressions. Objective 6.1 says I can simplify, add, subtract, multiply, and divide rational expressions. And that, my friends, is what we are going to do today. I want to start by just simplifying fractions. Now, rational expressions are rational. They're the same as fractions. They just got some variables involved here. So what I want to do to start is just kind of review, make sure we break down what it means to simplify fractions. So if I'm looking at 18 over 24, I can think of that as 6 times 3 over 6 times 4, right? Now the 6's would divide out, which would leave me with just 3 over 4. That would be the simplified fraction, right? 12 over 28. Think about what I can take out of both of those. I can say, well, 12 is 4 times 3, and 28 is 4 times 7. The 4's can divide out, and I'm left with just 3 over 7. So when we're simplifying fractions, we're dividing out common factors. That's all we're doing here. We're just saying what is in common to the numerator and the denominator, and then dividing them out. And we do the exact same thing when we simplify rational expressions. So let me show you what I mean here. Looking at letter A, 12n minus 4 divided by 24. Well, there's a 4 common in all of this, right? I could rewrite this as 4 times 3n minus 1 over 4 times 6. That 4 becomes my common factor. I can divide that out. I'm left with just 3n minus 1 over 6. That would be the simplified rational expression. Now this also works with quadratics and the like. To factor this, I can say, well, x squared minus 16 plus 60 is x minus 10 times x minus 6. And that's being divided then by x minus 10. Well, hey, in this case, x minus 10 is my common factor. It can divide out. I'm left with just x minus 6. Looking at letter C, m squared plus 12m plus 27. That would be m plus 3 times m plus 9 over m squared minus 5m minus 24. That would be m minus 8 times m plus 3. Well, look here. The m plus 3 is a common factor. I can divide it out. I'm left with just m plus 9 over m minus 8. And that's how we simplify rational expressions. We're just dividing out common factors. Now, let's talk about multiplying rational expressions. So let's review once again just by multiplying fractions. Remember, to multiply fractions, we multiply across. So 3 times 8 is 24. 4 times 9 is 36. And I say, is that fully simplified? No. All right, this is 12 times 2 over 12 times 3. Those 12's divide out. I'm left with just 2/3. Looking at letter B here, 2 times 7 is 14. 5 times 4 is 20. Is that fully simplified? No. A 2 is in common. 2 is a common factor for both of these. Divide out the 2's, I'm left with 7 over 10. All right, multiplying fractions, we multiply across. Now, when we multiply fractions, we multiply across the fractions, we're going to do something a little differently with rational expressions. The first thing that we are going to do, is we are going to factor the numerators and denominators. Instead of saying, okay, let's just multiply these huge things, we're going to start, if you look up top, we multiplied and then simplified. We're going to flip it. We're going to simplify, then multiply. So we're going to start by factoring, and then we're going to combine the fractions and divide out any common factors. So let me show you what I mean here. Let's look at letter A. Wow. Okay, so let's start by factoring this first fraction. So I can take out a 4. I'd be left with k plus 10 over k plus 7. And then I'm multiplying by 5k, which I can factor out from here. Let's see, and I'd be left with k plus 7 over, let's factor here. Let's see, we have, we have k plus 10, and what would we have? K minus 3. All right. And now what I do is I say, okay, what's common in my numerator and denominator that I can divide out? So k plus 10 can go, k plus 7 can go, and that's it. So I'd be left with 4 times 5k, so that's 20k, over, in my denominator, k minus 3. And there we have an example of us multiplying some rational expressions. Let's try letter B here. Ooh, look at all this factoring we got to do. Yeehaw! So this first one's going to be x minus 4 and x minus 1. And then let's see, what are we going to have here? We're going to have x plus 7 and x minus 4. And we're going to multiply that by, let's see, we have x, we'll have plus 3 and x minus 1. And then x plus 7 and x, let's see, that'd be plus 3. All right, let's see what we can divide out. So I see x minus 4 and x minus 4. I see x plus 3 and x plus 3. Notice, I do have x minus 1 and x minus 1, but they're both in my numerators, so I can't divide them out. And then x plus 7 and x plus 7 are both in denominators, so I can't divide them out. So what am I going to be left with here? I'm going to be left with x minus 1 squared over x plus 7 squared. And that would be my product when I multiply these two fractions. All right, let's do one more together, looking at letter C here. So factoring out here, we're going to have x plus 2 times x plus 2. And that's going to go over, let's see, x plus 2 times x minus 2. Well, there's one factor we can divide out already. 9x minus 54. Goodness, we can factor 9 out of that, and that'd be x minus 6. And then x squared minus 4, x minus 12, so that would be x minus 6 and x plus 2. All right, let's see what we can do. We can get rid of x plus 2 and x plus 2. We have another x plus 2, x plus 2. We have x minus 6, x minus 6. So the only thing I'm left with would be 9 over x minus 2. And that would be my simplified expression there, all multiplied out. Very good. So that's multiplication. Now let's talk division. Remember, when we're dividing rational expressions, we can turn it into a multiplication problem by flipping the denominator. Right? Multiplying by its inverse is same as dividing. So instead of 7/4 divided by 3/8, we can say this is 7/4 times 8/3. So multiply across. 7 times 8 is 56. 4 times 3 is 12. I can definitely take a 4 out of both of those. Is that it? I think so. So let's see. 4 times what gives me 56? 4 times 14. And then 4 times 3 gives me 12. So I'd be left with just 14 over 3. Fantastic. Looking at letter B here, 1/6 divided by 5/4. No, that's boring. Try 1/6 times 4/5. Boom, way more fun. 1 times 4 is 4. 6 times 5 is 30. 4 over 30 would simplify to 2 over 15. That's 1/6 divided by 5/4 right there. Okay, so when we divide rational expressions, we're going to follow these same steps with a little tweak. First thing, we're going to turn it into a multiplication problem. We're going to flip the second fraction, multiply by the inverse. Then we're going to factor both fractions. And then we are going to combine the fractions and divide out any common factors, right? So let's look at letter A here. 1 over n plus 9 divided by n minus 4 over 8n plus 72. So that would become 1 over n plus 9 times 8n plus 72 over n minus 4. All right, so now when we factor that, well, the only thing we can factor really is the 8n plus 72. I can take an 8 out of that. I'd be left with n plus 9. And n minus 4 is there. The n plus 9s obviously will divide out, and I'll be left with 8 over n minus 4, and that would be my quotient for this rational expression division. All right, now, looking at letter B, this is written a little weird, isn't it? So we have this fraction being divided by this fraction. So let's write this out. R squared minus 8r plus 7 over 20r minus 10 divided by 2 over 4r minus 2. Now that that looks a little more normal for us, let's flip that second fraction, turn it into multiplication. So we'll have r squared minus 8r plus 7 over 20r minus 10 times 4r minus 2 over 2. Fantastic. So now what can we do? We can factor. R squared minus 8r plus 7, so that would be r minus 7, r minus 1, over 20r minus 10. I can take a 10 out of that. I'd be left with r minus 2, times I can take a 2 out of this numerator. I'd be left with r minus 2, and then my denominator here is just 2. So what can we divide out? We can divide out the 2's, we can divide out the r minus 2's, and we would be left with just r minus 7 times r minus 1 over 10. Now notice, you can totally leave this in factored form. In fact, I'm encouraging you, do not multiply it back out. Just leave it here in factored form and you'll be feeling pretty good. Awesome. So we've done simplifying. We've done multiplying. We've done dividing. Let's talk about adding and subtracting. Now remember, whenever we add or subtract fractions, we must have common denominators. That applies with rational expressions as well. They're still fractions. Gotta have common denominators. So let's do just some fractions to start. 7/4 plus 3/8. Common denominator could be 8, right? I can multiply my fraction here by 2 over 2. So that will become 14 over 8 plus 3 over 8. And then once they have common denominators, all I need to do is just add the numerator. So that will be 17 over 8. Remember, the denominator doesn't change when we add. 1/6 minus 5/4. Ooh, this will be fun. Let's see, I think 12 would be a good common denominator. So let's rewrite these fractions with a denominator of 12. So that would be 2 over 12 minus, I need to multiply these by 3. So it would be 15 over 12. And then we just subtract. 2 minus 12, 2 over 12 minus 15 over 12 would give me negative 13 over 12. There we go. Hopefully we're feeling confident adding and subtracting fractions because we're going to do a lot of those. So when we add or subtract rational expressions, a little more fun process here. The first thing we're going to do is factor the denominators of both fractions. And if possible, simplify the fractions. Maybe there's something that divides out. That'd be nice. All right, then we're going to multiply the fractions by the necessary factors to get common denominators. Common denominators. And it's important that we multiply both the numerator and the denominator. Right? Because we don't want to change the value of the fraction, so we need to just multiply by 1. So we do that by multiplying both the numerator and the denominator. And then we're going to multiply out the numerators with those factors, and then we're going to add or subtract the numerators, whatever the problem is asking us to do. All right, so let's see that in action. Let's see that in action here. So 5x plus 4 over x squared minus 16, minus 5. Cool. So this one's pretty straightforward. We need to get 5 over x squared minus 16. So I'm going to multiply x squared minus 16. But imagine if this is 5 over 1, right? So I'm going to have 5x plus 4 over x squared minus 16 minus, and I'm going to go ahead and actually multiply this out. So I'll have 5x squared, 16 times 5 is 80 over x squared minus 16. Now remember, I'm subtracting this entire fraction here. So I don't have another x squared term, so I'm just going to have negative 5x squared. I don't have another x term, so I'm just going to have plus 5x. And then on 4 minus negative 80, that will become plus 84. And then my denominator, remember, doesn't change. It stays x squared minus 16. There we go. And there we have it. Looking at letter B is a little tricky here. 2x over x minus 5 plus 5 over 5 minus x. So notice there's definitely a relation between these denominators. What I'm going to do is I'm going to factor out a negative 1 from this second fraction, right? So if I factor out negative 1, That would be -1 times -5 over -1 times x minus 5, right? It'd flip the signs. So, with that being said, I see, oh, the only thing I really need to do is multiply this fraction, this second one, by -1. Okay, so I'm going to have 2x over x minus 5 plus 5 minus -1 would be -5. 5 minus x times -1, well, that'd be x minus 5. And that tells me 2x minus 5 over x minus 5 would be the sum of this problem. 2x plus -5 gives me 2x minus 5. Remember, our denominator does not change. Beautiful. All right, now looking at letter C, v plus 4, 5v minus 3, no common factors here, right? There's v plus 4 and 5v minus 3. Those are the factors in and of themselves, definitely not common. So that means I'm going to need to multiply each fraction by the factor it's missing. So 5 over v plus 4, and I'm going to multiply that by the 5v minus 3 over 5v minus 3, plus 6 over 5v minus 3 times v plus 4 over v plus 4. So let's break this down here. 5 times 5v is 25v minus 5 times 3 is 15 over, and your denominator you do not need to multiply out. I would just leave it in factored form. But I'm going to add to that. 6 times v is 6v, 6 times 4 is 24. And then I have 5v minus 3 and v plus 4. All right, let's see here. So combine our like terms. 25v plus 6v would give me 31v. -15 plus 24 would be +9, so that would be my numerator. And then remember, my denominator doesn't change, so it would still just be v plus 4 times 5v minus 3. And that would be the sum of this addition problem. Now looking at letter D here, this is one where we're going to have to factor the denominators to figure out what's really going on here. So we have 1 over x squared minus x minus 2. Well, that's x minus 2 times x plus 1. And we're going to subtract from that x over, let's see, what do we have here? X squared minus 5x plus 6. So that would be x minus 2 times x minus 3. So notice what factor is missing here, right? I need to include x plus 1 in this fraction. I need to include x minus 3 in this one. So I'm going to rewrite this as 1 times x minus 3 over x minus 2, x plus 1, x minus 3. And I'm going to subtract from that x times what factor was missing here, x plus 1, over x minus 2 times x plus 1 times x minus 3. So we see now we have common denominators, which means let's multiply out these numerators here. I'm going to have x minus 3 minus x squared plus x. When I do that subtraction, so that would become x minus 3 minus x squared minus x. The x's divide out. I'm left with just negative x squared minus 3. My denominator would not have changed. It's still x minus 2, x plus 1, x minus 3. And that would be the answer to letter D. All right, hopefully we're feeling pretty confident adding, subtracting, multiplying, dividing, simplifying these rational expressions. If you're feeling good, feel free to start on the practice problems. If you want to go ahead and get some more examples under your belt, definitely check out the sample problems. Feel free to do those or watch the video. Hopefully we're feeling confident, though. This was a lot to go through in one video. Let me know if you have any questions. This is Mr. Carter signing off. I'll see you next time.